Okay, question A. We're told we have a polarizing filter, we have some incident light upon it, and there's some light transmitted. Okay, so this incident light is unpolarized, and we know that its intensity is about I naught, and the amount that's transmitted is I. And we know from our 1/2 rule that when you have unpolarized light incident on a filter, then the polarized light that is transmitted has an intensity that is half of the incident intensity, I naught. But in this question, we're not looking at intensity, we're looking at the amplitude of the electric field. So we have to remember this fact, that intensity is related to the electric field by this equation. So we can see here that intensity is proportional to E squared. So I can rewrite this in terms of E. So E squared equals 1/2 or half E naught squared. Okay. Now what we'll do is we can simplify this by taking the square root of both sides. So ends up being like that. And we're told that the electric field of the incident light is 5.00 volts per meter. And so we'll just substitute that in. And we end up with 3.536 ... volts per meter. And to two significant figures, we'll have it to 3.54 volts per meter. Okay. Now with B, we're told that we have now a second filter, and the second filter is rotated by 45 degrees with respect to the transmission axis of the first one. Okay, so we'll use this equation, EY equals E cos theta, where y is just the transmission axis of the second one, the second filter. So we've sort of rotated the y-axis, so it's 45 degrees. And so we'll just take our E from the last question, but I will leave an extra significant figure on there so we don't introduce some rounding errors. Cos 45 degrees. And so we end up with 2.5003 something volts per meter. But again, we only want this to three significant figures. So we get 2.50 volts per meter.